Okay, today we're going to look at section 2.8, function operations and composition. So first we start with function operations and with functions. Essentially, f plus g of x is the same as f of x plus g of x. F minus g of x is the same as f of x minus g of x. F times g of x is f of x times g of x, and f divided by g of x is f of x divided by g of x. So if we let f of x equal 2x minus x and g of x equal 2x plus 1, find the following. So f of g of x, f plus g of x is f of x. Two x squared minus x plus g of x, 2x plus 1. Combine our like terms, get 2x plus x plus 1. F minus g of x would be, oops, that's squared, would be 2x squared minus x minus the whole thing, 2x plus 1. So 2x squared minus x minus 2x minus 1, or 2x squared minus 3x minus 1. Okay, f of g of x, well, we would have 2x squared minus x times 2x plus 1. FOIL, 4x cubed plus 2x squared minus 2x squared minus x. These cancel. 4x cubed minus x. And here we have 2x squared minus x over 2x plus 1. And at this point, we would not go any further than that. So if f of x is equal to the square root of x minus 4, and g of x is equal to 1 over x, what is f plus g of x? Well, square root of x minus 4 plus 1 over x. What about the domain? Okay, so we need to look at this. This has to be greater than or equal to 0. So x minus 4 must be greater than or equal to 0. So x must be greater than or equal to 4. Here we have a restriction on x. X cannot equal 0. Well, since x has to be greater than or equal to 4, it cannot be 0. So this would be sufficient. Okay, here we have the square root of x minus 4 over 1 over x. Now, here's the thing about this. You're going to immediately say, well, this is just simply x times the square root of x minus 4. And while that's true when trying to calculate it, we still have to take into account this x underneath in the denominator. So x cannot be equal to 0. But again, it doesn't matter because this part here makes it where x has to be greater than or equal to 4. Anyways, and since that excludes 0, we're okay. All right, now let's look at another one here. F of x is 4 minus x squared, and g of x is x cubed plus x. Now there's two different ways to do this. You can combine them and then do it, or we can take f of negative 2 and subtract g of negative 2. Well, f of negative 2 is 4 minus negative 2 squared. And g of negative 2 is negative 2 cubed plus negative 2. Well, this is 4 minus 4, which is 0. this is -8 minus 2, which is -10, which gives us a positive 10. Okay, f times g of -3. So again, I can do f of -3 times g of -3. F of -3 is 4 minus -3 squared times g of -3, which is -3 cubed plus -3. So this is 4 minus 9, which is -5. And this is -27 minus 3, which is -30. So I get 150. Okay, now we look at composition. The composite function f of g is denoted with this symbology here. The composite of f of g of x is the same as f of g of x. When finding the domain, look for restrictions on the inside function and then restrictions on the end once the composition is complete. So we have f of x equals x cubed minus 9, and g of x equals x plus 14. Find the composite of f and g of 3 and the composite of f and g, or g and f of -2. Well, first of all, we don't need to consider any restrictions for either of these functions, but we may have something at the end. I doubt we will, but we may. So what do? I have f of g of x. What that means is for every x here, I plug in g of x. Now that's going to get kind of messy if we would just work this out, but let's look at what this is. This is x plus 14 cubed minus 9. Okay, that is composite of f and g of x. Now, like I said, we can cube x plus 14, but do we really need to? We can just find f of g of 3 by simply going 3 plus 14 cubed minus 9. So we have 17 cubed minus 9 minus 9, and that gives me 4,904. Okay, now g and f of x, simply g of f of x, which means x cubed minus 9 for that, plus 14. Again, if we're finding the composite of g and f of -2, we have -2 cubed minus 9 plus 14, which is what? -8 minus 9 plus 14. And this is just a coincidence that we would get that like that. Okay, so let's look at some more of these. We're going to find f and g, the composite of f and g of g of x and g of f of x, and we want the domain. So looking at the equations we have here, they're all no restrictions on the domains of either equation. So to find positive f of g of x, simply take this and put it in for here. I have 3x, oh, not x, 3 times 2x minus 2 minus 2, which is 6x minus 6 minus 2, which is 6x minus 8. In my domain, it can be anything, so all reals, negative infinity to infinity. Now for the composite of g and of f of x, we have 2 times 3x minus 2 minus 2, which is 6x minus 4 minus 2, which is 6x minus 6. Again, no restrictions. Negative infinity to infinity. A line will always have no restrictions. Okay, so now let's look at this. Doing the same thing. However, g of x gives a restriction that x cannot equal 0. So we have to keep that in mind throughout the whole thing. Now, f and g of x, we simply take g of x and plug it into f of x. So I have 8 over x cubed, which gives me the domain negative infinity to 0, not inclusive, 0 to infinity. Because the only thing here that x cannot be is 0. Now going the other way, composite g of f of x, we have 2 over x cubed. And again, we already started out with x not equal to 0, but even if it wasn't there, it's going to be there. So our domain is going to be the same. All reals except x cannot be 0. And I believe, nope. Okay. Couple more to do here. All right, here we have to look at f of x. We have a restriction. 3 minus x must be greater than or equal to 0. So x must be less than or equal to 3, or negative 3. So we have to take that into mind for any of these functions. So going to composite of f and g of x, we plug g for x, and I get the square root of 3 minus x minus 5. Doing a little work here. This is 3 minus x plus 5, which is 8 minus x, square root of 8 minus x. So now we have to look at this. 8 minus x must be greater than or equal to 0. So x must be less than or equal to 8. However, we started off that it must be less than or equal to 3. So that's really where we're at. Whichever of these two limits the domain the most, that's the one we work with. So now let's look at the composite g and f of x. There we're just going to have the square root of 3 minus x minus 5. And the only restriction on that is the same, this, so negative infinity to 3. It comes from here and it comes from here. Okay, so here we have another one, 2 fractions. So I have x plus 3 cannot equal 0, so x cannot equal negative 3 from f of x, and x cannot equal 0 from g of x. So looking at the composite of f and g of x, we have 1 over 2 over x plus 3. Okay? So if I multiply this by x over x, I get x over 2 plus 3x. So now I have a fraction with a variable in it, which cannot be 0. So I say 2 plus 3x cannot equal 0. 3x cannot equal negative 2. X cannot equal negative 2/3. So now I have 3 restrictions. And I think the easier way, I mean, we could do this in what do we have? Negative infinity to negative 3, negative 3 to negative 2/3, and you know what? Negative 2/3 to 0, you know what? 0 to infinity. Or x does not equal negative 2/3, negative 3, or 0. Either of those will work in my mind, depending on how it says to list them. Okay, so now we're looking at g, positive g and f of x, which is simply 2 over 1 over x plus 3. Actually, that's an error. We have our limitation, so we have 2 times x plus 3 over 1, which is simply 2x plus 6. However, we have this we have to concern ourselves with. X cannot equal negative 3. Looking at negative infinity to negative 3, and you know at negative 3 to infinity. We have to go back here because in this case, this would not be an issue. It says the inside. So we have to worry about G. So where was that? Here. This can go away. And this can go negative infinity to negative 2/3. There we go. This stuff is easy to get lost in. And that brings us to the difference quotient. The difference quotient of a function is found by computing the following. F of x plus h minus f of x over h. Find the difference quotient for the function. So I need f of x plus h. F of x plus h. That's negative 2 times x plus h plus 5, which is negative 2x minus 2h plus 5. So we have f of x plus h minus f of x over h. Well, I have negative 2x minus 2h plus 5 minus negative 2x plus 5 over h. Negative 2x minus 2h plus 5 minus a negative is plus 2x minus 5 all over h. Negative 2x, positive 2x, 5, negative 5. I get negative 2h over h, which is negative 2. So, before we go on, let's talk about a difference quotient. What is a difference quotient? Well, you may recognize the number and wonder, This is typically used for a curved line, a curve, not a line. And essentially what it is, if you have a curve, say something like this, we can pick a point, f of x and f of x plus h. And then we have this line. Well, the difference quotient is the slope of this line, which is called a secant. So in this case, our function was a line with a slope of -2. However, what if we don't have a line? What if we have something like this? So now I need to find f of x plus h. That's 5 times x plus h squared minus 2 times x plus h plus 3. And 5 times x squared plus 2xh plus h squared minus 2x minus 2h plus 3. So we have 5x squared plus 10xh plus 5h squared minus 2x minus 2h plus 3. We have 5x squared. I have minus 2x. I have plus 10x times h. I have minus 2h plus 5h squared plus 3. And now here's where we get nasty. So now I want the difference quotient, which is f of x plus h minus f of x all over h. Well, here's f of x plus h, 5x squared minus 2x plus 10 xh minus 2h plus 5h squared plus 3 over negative or minus 5x squared minus 2x plus 3 all over h. So this will be minus 5x squared plus 2x minus 3. Save us some trouble. Negative 5x squared, 5x squared. 2x, negative 2x. Positive 3, negative 3. So that leaves me with 10xh minus 2h plus 5h squared over h. And we can divide out the h, and I get 10x minus 2 plus 5h. So in this case, it doesn't necessarily work out pretty. It's not a line, so it will vary based on what part of the curve. This is essentially some form of a parabola. So the slope between 2 points on it is going to change depending on where it is, which is why we get something like this. Okay, that covers section 2.8. That's all I've got. That should finish up chapter 2. I'm going to be working on your homework and getting ready for the exam. Have a good night.